Hey, welcome again, and we're going to be looking at this next section here. It's AP Calculus, AB Manual. This section is going to be differentiation and the natural log function. The natural log function, the thing that looks like this, natural log of x or u or whatever else you want to input for your variable. Again, all the usuals. Thanks to Stu. Thanks for all the cool toys. Let's get started. So the first thing that I want us to do is, if you guys have a TI-84 calculator, you can go ahead and input these things, but let's just use the data that we already have here so we don't spend too much time doing all the extra work. If I input x, and this is y primed, which is the derivative of natural log of x. That's what this piece right here is, all these numbers. So I want you guys to take a look and notice these. This is 1, and that's 1. This is 2.5. 3.333, 4.25, 5.2, and so on. And if you're noticing it, if I wrote this bottom as a fraction, it'd be 1 over 1. This next one would be 1 over 2. Then this would be 1/3, 1/4, 1/5, and so on. Hopefully you guys see a connection in the numbers right now. So what's the relationship when you look at the value of x and the value of the derivative of natural log x? It should be clear. The derivative is what? What is it? It's the reciprocal. So you do 1 over this number, and that'll give you the derivative. That makes sense so far, at least with the numbers that we have. And here's how it actually works. Here's the natural log. If we take the derivative of the natural log, it's going to be 1 over x, if it's just x. The difference is, let's say that inside piece wasn't just x, but it's actually a function. Well, it's going to be 1 over that original function times its derivative, du dx. Another way of thinking that is u primed over u, the derivative on top, the original on bottom. Now it's the same thing as if we were taking the absolute value of u in here. So if we took the derivative of natural log of u, it would be 1 over u du dx. U cannot equal 0 in this case. Why does it have to be equal to or greater than 0 in the other case? Because you can't take the natural log of a negative number. Can't do that. Alright, so let's look at these pieces here. Each of these have not just x, but some slightly different function. That makes it a little bit harder to deal with, but not really that bad at all. So if we were to formally do this, we say u equals 4x, then we figure out what du dx is, or du dx. If we took the derivative of u with respect to x, it's just 4. So then y primed is u prime over u. This is u prime, by the way, which is 4 over 4x. Well, that's kind of interesting. Y prime, by the way, is 4 over 4x. That means y prime is equal to 1 over x. It still comes out to be the same. So this constant here seems to not really make a difference. We can look at that later and see why. Now this one, it will be a little bit different. U equals x squared minus 3. Then du dx, or u prime, let's go ahead and do it that way, equals 2x. Easy enough. Then y prime is u prime over u, which is just 2x over x squared minus 3. Easy, lemon squeezy. Let's see if we can do this one without having to do a whole lot of work. If this is our u, we know that's already our u, but what's u prime? Take the derivative of this inside piece. It would be 6x minus 5. I get the 6x by bringing the 2 down. 2 times 3 is 6. This x disappears. This goes to 0. So y prime is going to be u prime over u, 6x minus 5, over 3x squared minus 5x plus 8. Again, we get the derivative on top and the original on bottom. Now this one, I could say u equals x to the 1/2, and then u prime would equal 1 over 2x to the 1/2. Now, another way of thinking about this, this is kind of shortcut. You have to do a chain rule and a bunch of other stuff there. But what I want to do is, instead of trying to do the complex derivative in my head, I want to do some algebra first. So if I know y equals ln of x, that's the same thing, or square root of x. It would be the same thing as y equals natural log of x to the 1/2 power. Now when you have a power of a log, we're allowed to bring that out front, as per earlier videos that we were looking at. So that equals y equals 1/2 natural log of x. Okay, now this is much easier to take the derivative of. This constant out front, it's going to just come right back. But what's the derivative of natural log of x? That's just 1 over x. So y prime is equal to 1/2 times 1 over x, which if we put that all together, 1 over 2x. And the first one is done. Give you guys a second to take a look at this. If you need to, go ahead and pause the video, but let's move on. So we got lots of rules going on, especially this new natural log rule. We need to find the derivative of these 4 functions here. Now the difference between these 4 and the last 4 only dealt with the natural log, but now we're going to deal with the other ones: power, product, quotient, trig, and now we're going to do natural log. So first, when I look at this one, I see 2 functions. I see the x squared and then this natural log of x. Now when we work these out, if we say that x squared is u, then u prime equals 2x. And let's say that natural log of x is v, then what's v prime? It's 1 over x. For a product rule, y prime is going to be u prime v plus u v prime. Take the derivative of 1 for the first half, and then take derivative of the other for the second half, and we're multiplying them. So for the first one, it's going to be 2x times v, which is natural log of x, plus the second one's going to be x squared times 1 over x. This is our derivative, by the way. That should have said y prime. Now we just simplify a couple things here. This squared and this x are going to reduce down to 1. We have 2x, natural log of x, plus x. And that's it. Next, what do we have here? A quotient rule with a high and a low. If you haven't memorized quotient rule, you need to. One of the easiest ways that I use to memorize it is that the derivative is equal to low d high minus high d low, square the bottom, and off you go. Or just say low low. Low d high. The low is x. The derivative of natural log of x, which is the high, is 1 over x. So that's my low d high. Minus the high, which is natural log of x, times d low. Well, the low is x. The derivative of x is just 1. Then we're going to have low low, or x squared, the bottom squared. Let's do some algebra. What reduces? These x's become 1 over 1, and nothing happens over here. So I basically have y prime equals 1 minus natural log of x over x squared. This second one is similar, but just a little bit different. And sometimes you might notice that because it's so similar, we don't have as much work to do. But I'm still going to do it from scratch. What's the main change? On top now we have the high is x and the low is natural log of x. So I'm going to use the same template here. Low d high minus high d low over low low. Low d high, that means natural log of x times the high, which is just x, minus high d low. High is x, the derivative of the low is 1 over x, all over natural log of x, all that squared. Well, if I were to simplify this a little bit, there's not much to do, but it says x natural log of x. Whoops, I messed up there. This x should be a 1, because when I do d low, the derivative of x, or the derivative of x up here, pardon me, is 1. Let me erase this. So this is just natural log of x minus these x's reduced, minus 1, all over natural log of x quantity squared. So y prime equals this for the second one. Or for the third one. And for number 6, y prime equals 1 minus natural log of x over x squared. This last one, it's going to be a chain rule. Let's do it in purple. Here's the inside. Here's the out. It's always derivative of the outside of the inside times derivative of the inside. So y prime equals 5 times something to the 4th. We leave the inside alone the first time, but then we multiply it by the derivative of the inside, which in this case is 1 over x. The only way that we might see this rewritten is 5. We have natural log of x to the 4th power all over x. So what were we looking at here? At all the rules, all 5, power, product, quotient, trig, and natural log. Put them together, and these are the kind of functions that you get